sorry, I couldn't make my laptop working, so there won't be any demo in the talk, and I'm going to try to stick to the 15 minutes because I'm standing between you and your lunch. Okay, so I'm going to talk about autobiography-based prediction, and just such that we can, well, usual structure, but just such that we can kind of anchor our stuff, let me anchor this with a running example. So let's imagine an AGI agent called Robbie the robot, who's currently watching TV. He watches a dramatization of Homer's Iliad, maybe the movie Troy or something like that. On the screen he sees the fight between Hector and Achilles. And then there is a voiceover narration, comments on the story. Robbie obviously had seen these kind of stories before. He had seen fights, he had seen knights, he had seen fencing, other stuff, and he has a feeling that this is not going to end up well. Suddenly the program is interrupted by a commercial, and then frustrated Robbie tries to envision the way in which the story is going to end peacefully. Now, what this kind of tells us, and I don't need to tell anybody, that the reasoning about the future is a big deal in AGIs. And the most widely used approach for prediction is model building followed by simulation. And for instance, Ben's claim 10G towards moving to AGI says the simulation is a good way to handle episodic knowledge. Running an internal world simulation engine is an effective way, and I agree that this is one of the good ways, but I'm going to try to present an alternative. So let's think about how the normal way to do this works. Offline, you build a model out of data and a priori knowledge. Then online, when you are actually doing the stuff, then you are in a cycle in which you are sensing the environment, you are initializing the model with the current state, then you let the model run to simulate, let the model or multiple models maybe move into the future, and then you stop at some moment and read out the state of the model, and that's going to be your prediction. And optionally, if you are doing this kind of online learning or stuff like that, from time to time you can update your model based on the new things you have seen. So, and then I'm trying to propose something alternative. What I propose that we do not build any kind of model, we don't do any kind of offline or online learning. What we are going to do is that the unprocessed data, and I mean unprocessed, sensed by the agent is recorded as stories in the autobiographical memory. So this is a flat recording, no processing whatsoever. So no model building. Now, then instead of this simulate readout cycle, what I'm going to have offline nothing, well, recording of the autobiography. And then online, what I'm going to do is I sense the state of the environment, keep some part of it in the memory, in the something like which is called, I call it focus, but short-term memory, whatever you want. And then I'm going to align stories from the autobiography with the current state. Then I'm going to extend these stories in the future if I want predictions, or in the past if I want explanations, or in some other direction if I want summarizations or stuff like that. And now, then I'm going to take these extensions, which are going to be explained in terms of the past, in terms of my autobiography, and I go back and I interpret them, the extended stories, in terms of the current state. And optionally, I record whatever I see again into the autobiography. All right. Now, this sounds somewhat stupid. So does this thing even make sense? Well, there are two big questions immediately. One of them is whether can this thing match the predictive power of a model-based approach? And second, isn't this terribly inefficient? Isn't the model-based approach a lot more efficient than this? Okay, so let's discuss first about the predictive power. Well, the question is, where are models coming from? Well, when I'm building models, we are building them either from scientific or engineering knowledge, or from experimental data, which is a kind of an autobiography. And I am going to argue that both scientific and engineering knowledge and experimental data can be expressed in narrative form. In fact, humans take in narrative forms a lot better than other forms. Like, for instance, when you learn calculus, that was a story. And giving examples, it always makes us easier for us to learn rather than drawing big tables, right? I mean, learning the table of multiplication is a huge chore, despite the fact that it's a tiny table. So we don't really learn well from databases. Now, I'm going to argue that there is no reason why the AM-based approach should provide lower predictive power than the model-based one. And how on earth can I make a statement like this? Because you can cheat. What you can do is that if you really, really desperately want to match the model-based approach, then you assume that your complete autobiography is relevant, and then cheat. At the moment in which you have to do the prediction, then just build a model just in time. Right, it's going to be terribly inefficient, but at this time, right, you can get the same model which you would have gotten before. Just get it just in time. Now, of course, the performance is still a problem. So, performance, there are two questions. One is memory, one is processing time, okay? Can we afford to store the full autobiographical memory of an agent? Yes, say yeah. If you are talking about something like a human. Because you see, I don't want big data. I don't want to store all the data humanity have ever produced. What I want to store is all the narratives which have been seen by a given human. And that's not that much. Joshua was saying something similar. Right? So if you write out in a narrative form your life experience at the rate of 1 sentence per second, you end up with 60 million sentences of a 30-year-old person, or something like 80 million sentences for a 4-year-old child. And, well, 80 million sentences, efficient encoding, I can stuck it in the RAM of this laptop. It's a large data set. You don't want to run some computationally complex stuff on it, but it can fit. Another question is how many stories are relevant at any given time, and they are not that many. For instance, an airline pilot is required to have 1,500 flight hours before it can fly your plane from Quebec City to wherever you go. The experience of a trial lawyer is limited to at most 100 cases, and of course, books they had read and other stuff, but still, it's not such a big data. Now, there is this question, is the beauty of the models. Wouldn't the extracted models would be more compact and elegant? Yes, I would like them as well, provided they are compact and elegant. And all of us have a bit of a physics envy, and we would like to have those kind of nice models. And in physics, it seems that it's partially possible, but in things like social behavior and others, those models might not exist. So, okay. So I was working on this little cognitive architecture for a couple of years, and it's called Xapagy, and it implements this model. The goal of Xapagy is to mimic the way humans reason about stories. There is a pidgin-ish simplified English language, simple sentences, subject, verb, object, subject, verb, things like that. And there is a subject, communicative verb, scene, and code, which is used to do reasoning about things like hypotheticals and possible futures and explanatory things and stuff like that. Subjects and objects are represented as instances. Attributes of instances are represented as overlays of concepts. Sentences are mapped to verb instances. Now here comes where it starts to get weird. Newly created VIs are entered into the focus, which is the short-term memory. During their stay in focus, VIs and instances acquire salience in the autobiographical memory. They are connected by links, succession, elaboration, summarization, context relation, coincidence, precedence, this kind of stuff. But then after they expire from the focus, instances and VIs can never return. Whatever ended up in the autobiographical memory, it is never going to be changed. Maybe there is a gradual decay, but I didn't find it as of yet necessary to implement something like that. So your autobiographical memory is a short-term mesh of verb instances which roughly are equivalent to sentences, but that doesn't, it's not changed. And nothing is ever recalled. Instead of recalling, you have shadowing. Every instance you are encountering is shadowed by a weighted set of instances or VIs from the autobiographical memory. There is a small story about how the shadows are meant. I think I have to skip this. If you want to talk to me on the, I'll show them. So this is the align step, what I mentioned. Now the next step is to extend it. And so you have what you have seen currently. So Robbie had seen, Achilles fighting with Hector. Then Achilles and Hector is being shadowed by previous things which he had seen. And then this thing is extended into the future. So in this case, let's say this is formed by a triplet of a focus object, a shadow object, and a link object. And this is a triplet called focus, shadow, link. So let's say you have in the focus Achilles sword, its sword is penetrating Hector, and this is shadowed by Mordred, sword penetrating King Arthur. And then the link from this one is a succession link which says that Arthur changes to be dead. And then the shadowing process generates a bunch of these focus shadow link objects. So, and this is the extend step. Now, the interpret step comes because, okay, so I kind of had a prediction there that, Arthur is dying, but that's Arthur, okay? So I have the prediction now that somebody is dying, but that's not what I'm curious of. I'm curious of whether Hector is dying or Achilles is dying. So that means that I need to map those predictions which have been done by the link component of the focus shadow link object, map it back to my current name. So the question is, okay, I'm predicting that of one combatant of each one. So what I'm going to do is I'm going to inverse the shadowing relation. In this case, the way in which it works out for one particular run is that the inverse shadow of Arthur is, there is a weight of 0.11 on Hector and 0.03 on Achilles. So this creates an object which is interpretation of an FSL object, an FSLI object. So from that step, I am going to have these two. One of them is the prediction that Hector changes dead, and that's going to have some weight, and the other one is that Achilles is changing that. So I'm going to have a bunch of these predictions in the system. Now, again, depends on how many stories I had seen, but if I assume that I had like 20 or 30 or 40 fights I had seen in my life, then that's going to generate a couple of thousands of FSLs and probably about 10,000 FSLIs. But then many of these FSLs are going to have similar or close interpretations. These represent some kind of prediction and some kind of support for this prediction. So what I can do is I can cluster these together, those which give me similar predictions, and this thing is called a headless shadow, because it looks exactly like the focus and the shadow, except that what is in the focus is not really there, that's just the prediction. So then the question is, how do I combine the supports? And again, the supports depend on what kind of prediction I'm making. If my prediction is a prediction, it goes in the continuation, it goes towards the future, then the type of links, succession links, coincidence links, and elaboration links help me. Those have a positive contribution. Shadow and predecessor links decrease the support. So let's try a little experiment. So I had implemented this stuff which I had done, and then thrown in a couple of stories which were like historical stuff. Fight between, so I'm looking at the fight between Hector and Achilles, which happens kind of towards the end of the Iliad, and then you had the fight of Hector and Patroclus, which is kind of before, and then Achilles and Penthesilea, which is in a completely different ancient epic. the fight between King Arthur and Mordred, all these things end up in the death of the defeated person. Then a bunch of boxing fights, Cassius Clay versus Sonny Liston, and Mohammed Ali / Cassius Clay against George Foreman, and some unnamed sports fencers. And these did not end up in the death of the defeated person. And then this is how it looks like in Xapagy, the description. And then let's see, what do you get with through the shadow maintenance? So this is at the end of the story. So this is interesting. So it's interesting, for instance, how the shadows get set up. Hector is shadow, the strong shadow is Penthesilea. Penthesilea is an Amazon who is killed by Achilles, and Achilles falls in love with her at the moment in which he kills her. Then there is the weak fencer, then there is Arthur, then there is strong fencer, and then there is Hector himself in a previous story, in the scene with Patroclus. Now, how come that Penthesilea, who happens to be a lady and stuff like that, is the strongest, while Hector himself is a weaker shadow? Well, because first Penthesilea was fighting with Achilles, and second, she was on the losing side. So, due to the dynamic nature of the system, you don't, I mean, I can track of what's happening, but sometimes it's not obvious what shadows what, because sometimes things which are yourself are going to get weaker shadows. Okay. So, okay, now the continuation initialize. So let's see the moment in which the television cuts the commercials, where these are the continuation headless shadows which appear, and what appears there is that, okay, so Achilles is victorious over Hector with some weight, Hector changes death with one weight. Hector concedes defeat to Achilles. This is not what is going to happen, but because we have seen so many boxing matches and fencing bouts, that's a valid prediction. And then guess what? There are also some predictions in which Hector is the winner, because it can happen. Now, if you want to predict an outcome, if you want to imagine what's going to really happen, what you can do is that you instantiate the strongest prediction, put it back in your memory, instantiate it, put it back in the focus, and then let it run a bit. Make the next prediction, then you instantiate that, the strongest one, and the strongest one, and the strongest one. And then if you do this, what is going to end up, this is what you're going to end up with, which is, so Achilles is victorious and Hector changes to be dead. And this roughly corresponds to the way the story we are going to unfold, although it's not going to predict the details of the manner of Achilles killing Hector. Now, what if I want to have an alternative outcome? Let's say I want to find a way in which this is not going to end up with the death of Hector. Well, what I can do is I can cherry pick some of the weakest continuations. And for instance, you can cherry pick this one from the Hector concedes defeat, because this is coming from stories like boxing or fencing in which they don't end up dead. Now, one of the interesting, and then you let it run, and then you are going to have another prediction, and then you pick. Now, one of the interesting phenomena, which is kind of expected, is that you don't need to force through a long series. It's enough for you to steer a little bit. Like in this case, the first time you have to pick the third one with the concedes defeat. And on the second one, if you choose the one with the shake's hand of Hector, Achilles, after that the one with the Hector dying is not going to be the strongest. And that's because by you choosing and steering the story a little bit toward the peaceful ending, the shadows are going to readjust. Stories which had a more peaceful ending are going to get stronger in the shadow, and well, that's what you get. Okay, and this is what you get if you force, it maintains, and that's it. So I argue that prediction-based autobiography can be an alternative, not always, not in all situations, sometimes works, so forth. I assume that if your knowledge is exclusively the autobiography, then this approach can be both easier and more efficient than model-based approaches. And that's fine.